warm introduction and for setting the context for today. Next, speaking on towards proactive security in critical infrastructure, we have Mr. Bapu BindhumadhavaHead. A respected and esteemed leader in the industry, Bapu S. BindhumadhavaHead is the center head of the Power Grid Center of Excellence in Cybersecurity. As a former scientist G and senior director at CDAC, he has a 35-year career focusing on real-time systems and critical infrastructure security, network security, smart grids, and cyber-physical system security. His influential work includes 65 refereed papers, multiple patents, and he was conferred the Dr. APJ Abdul Kalam Gold Medal for Research Excellence in 2017. He is a highly active member of the community, holding fellowships with the IETE and IE, and having served as the chair of the IEEE Computer Society Bangalore chapter and the Computer Society of India Bangalore chapter. A former board of director for NICSI, Government of India. Please welcome Mr. BindhumadhavaHead to the dais.
Thanks for that introduction. So, like I told Ravi Shastri, right? I was asking him at what context. Is it a commentator or a head coach? Because I'm the opening batsman, right, for the day. So, with that particular thing, let me get on to the business. I just took a, I think enough. I picked up a topic because it was on security and privacy, right? But my forte is not on IT side. It's more on critical infrastructure. So that's what I was just trying to see whether I can marry this proactive security, which people are talking for a very long time now, especially in the operational technologies, and try to see how this is applicable in critical infrastructure. So something little is picked up for the agenda, but you can stop me whenever you get bored, right? The idea is, I don't know how much of time I've got. Half an hour? 20 minutes? Okay. So trying to sort of have a build-up for what critical infrastructure means. So as per Government of India, NCIAPC is the body which defines the critical infrastructure in the country. 16 critical infrastructures have been defined in NCIPC guidelines. These are available online, so people can have a look at it. So this includes both continuous process industry as well as discrete industries. So that's the gamut of the things which are covered. And second thing is how this particular thing becomes important. I will concentrate only on the power grid in the critical infrastructure, because that is the area what we are working on, and we would like to sort of say what are the things which we are doing in this particular area. And future is cyber resilient systems, which people are talking, and how this thing is coming up, and what are the probable technologies and sort of areas of interest in this particular area. So a small definition of proactive security. Then I have taken one small example, the infrastructure especially, and taking an intrusion detection, which is the basic building block for a monitoring system, which is forms to the proactive security. Of course, I have to say this with all this general thing, what exactly Power Grid Center of Excellence is trying to achieve and do it. So I'll just have some 2-3 slides on that particular thing. What are the current projects running and how we are trending to go forward. Conclusion, of course, how do we conclude this? So I think this is a standard start by any of the critical infrastructure talk giver. So they talk about industry, whatever, .0. Okay, I think some of us have stopped here. Pointer. Okay. So some of us have stopped at Industry 4.0, but 5.0 and 6.0 in the offing already. So that's where we are more. So we talk more on cyber physical systems, but the cognitive layer is already built onto the cyber physical system. That's why so-called this AI flavored technologies are brought into this particular space. And it's applicable for all discrete as well as continuous process industries. So there you see these things, right? So the 5.0 has got some intelligent systems in place. So that's what it means. So going to only the power grid portion, these are the basic components which are there. So I thought this slide is very much important because conventional generations which are there and the renewables which are getting integrated into the grid becomes important, and how this complete whole system becomes very important in terms of data in transition, data at rest, as well as data set generation for experimentation. So these are the three areas of importance which is there. If you see this block, this lower block is very important for this particular symposium, which talks about data, where the sensitive data which is made available, and there is a lot of attacks which have been taking place with the data which is available openly, especially the smart grid data, how the consumer utilization is being tracked, and there is a lot of attacks which is happening. And not only that, that has led to a lot of thefts into the housing areas also. So it is the physical system, which is the electrical system, and the cyber layer is also embedded onto that particular thing. Now it is only how the journey has traveled across. Okay, we have to look into that particular thing. So in this particular system, there are two variables. One is fault, the other one is the attack. Right? The physical system has got fault. You will be able to have some protection for that fault. And the cyber layer will have an attack. How do you mitigate those attacks? So these are two things which has to be worked on. I think everybody yesterday also were talking about the next generation systems. So we are also talking about next generation power grid whenever it happens. Okay. So there is an electrical infrastructure, there is a telecommunication thing, there is an internet and AI and information data net which is available. These are the four intersections which will be the main component building blocks for the next generation grid, power grid. I'm talking about power grid. And the same thing might be applicable for other things also, but this is very important thing so that we are trying to address. So this is a very old slide which I've been using for the last 15 years. So still it is apt, and that's why I was just trying to sort of bring in this slide again. So like I told, this infrastructure is well understood by power system engineers. This is well understood by IT folks, right? So the fault, how to sort of have protection, and attack, how to mitigate on an IT system is well known. Now what happens? If you see down, there are big systems, there are small mobiles. And the communication is starting with your PLCC communication, which was happening long olden days, microwave, and VSAT communication, and whatever Gs we are talking about today, 5G or 6G or whatever. So that becomes a reality in this particular layer. And there are a lot of security aspects looked into this, and when it comes close to the consumer, the privacy issues are also looked at. Now the scenario is like this. So this things meshes with each other. So this is a large and complex system which has to be dealt now as on today. What does it mean? If you are doing a application, power system application on this particular system, the fault and the cyber attack isolation is a classification problem. So if you classify on this particular system, whether it is because of a fault, there is a blackout or a grayout, or it is because of a cyber attack. So 50% of the problem is solved. Next is when it comes to the applications. So this is how the system is trying to look today. Not that exactly like this, but there are only few interventions which has happened on the physical system. So over a period of time, this is how it looks. So this is what is the definition of smart grid which people are talking about. And this has got some 7 clouds which are interconnected for information exchange and data exchange. So starting from consumer, and there is markets, there's transmission, distribution, generation. So that's how the whole setup is for the data exchange between these particular things. Now, if you see, these are the major applications in this particular domain, right? So you would have heard about dynamic pricing. So can I do a dynamic pricing for the electricity consumption of a consumer? Okay, and can I have some healing system, especially the system what is on the top, when the cyber layer and the physical layer very close meshed together, can I have a healing system? Wide area networks when it comes to the compute or the networking systems, and wide area protection, and can I do some sort of islanding for the physical system? So can I run these models over there? For all of these things, the asset management becomes an important thing, and you have to monitor this asset. And you have to do a real-time simulation and contingency analysis, and you have to do some auctioning using your energy market space. So for all these things, you have to share data, and you have to continuously optimize it and intelligently respond. So just long time back, we had done some computation for if you have to operate this, the whole system as a single control system with the generator and the distribution or the load. Okay, approximately you need some 10 petaflops of compute to handle with a response time of 4 seconds. The model has to be responding with 4 seconds. That is a stringent requirement, but you have to do the simulation faster than that because you have to sort of catch up the real-time system, right? So that's how the whole thing you have to look for. When it comes to storage, we'll be operating in zettabytes of storage. So this is sufficiently good enough data which is generated, and you need a so-called high performance computing. So that's how we made a classic case for this. This is a real application which is there for any supercomputers built in India today. So the 3 things what I was trying to mention, the data in transition. So mostly when you have a client server or a communication channel where you exchange data, and data rest and data sets. Yesterday also there was a lot of discussion and debate on data sets, especially the scientific data sets for research and other aspects for modeling what you have to get. So this is what is the requirements for in this particular space. Now what are the possible attacks on that particular system, right? So there are some systems which are there, networks which are there. So classic attacks which are possible on an IT system is also possible on this particular thing. And there are some cyber resources, again the systems, and different types of networks and the connectivities based on the requirements it is configured. And how do we or what do we control the physical systems? These are all the things in electrical parlance, what is being controlled. At generation, these are all the things, transmission and distribution. And what will be the impact? Either a fault or an attack, the impact is that, right? So it is the stability loss of load, contingency and economic. If you want to do economic dispatch, pricing and other things, you need the models there. And if you want to push it into the extreme, that is the gray out or a blackout, that is also possible as on this one. So this is how the attack, resource and control and impact, because I saw data, innovation and impact, right? So how is it applicable in the area of the power sector or a power grid sort of scenario? So this was the build-up for the cybersecurity thing, which is existing. Certain things are happening, but what is future, right? So these are all some things we are trying to sort of do a retrofitting for a system which is existing. Historically, if you see critical infrastructure, especially the power sector and other things, the cyber devices are minimum 7 to 10 years old. Okay, so we are trying to sort of do something with those devices. So you do a retrofitting. So the solutions are all mostly retrofitting sort of things which are happening. So when you do a retrofitting for a solution at data rest, what is that required? In transition, what is required, right? There is a communication channel which is doing a plain text communication. Can I encrypt? So these are the questions which are there. If I encrypt, both the devices are not under my control, what do I do? And nothing is allowed to be put on these devices which are there because they are 7 years to 10 years old. So the performance will be at stake, right? So these are all the questions which we have to look at. So taking it to the next level, how do we sort of, these are the jargons which are already in space and people are looking at. So cyber resilient, autonomous, not automation. So it should be autonomous, so it is intelligent. Try to sort of get the technologies in the autonomous space. And how do we sort of apply? So what is that you have to arrive at that cyber resilience thing? So you have to do something. If you are doing some planning stage, you have to go by design. If you are doing at operational stage, you have to go by operational strategy, what is required. That means the system should sort of detect and resist. That is for the operation. By design, you might have to have certain things to be built as an input. So the foundational systems for this cyber resilient system is cyber resilient system design and control and zero trust architecture. ZTNA also is one of the things, network architecture. But overall, you might have to see how to look into that. And the autonomy. So how to make this autonomous system? That means basically, can I make the self-healing term possible in this particular thing? So that's how we are going to look at. And what are the technologies or the areas of research which are being applied? Like you are telling in the thing, it is not the fundamental research, it's the applied research area. So these are all the things which is being actively looked at. So this is actively looked at in the Power Grid Center of Excellence. So that's what I just wanted to put across. So this is what is the future thing, what we are trying to address. So it becomes a cyber resilient system for a period of time. Now that is as far as the critical infrastructure is concerned and what is its future. Now there is already security which has been discussed for the last 10 years, at least in the operational technology space. Of course, 30 years in IT space and 10 years people are trying to see, 10 to 12 years, specifically from 2012 or 2010. That is how the people have started looking in the space of operational technology or critical infrastructure space. This is basically a wiki definition. There is nothing rocket science which has been put in this slide. I just wanted to sort of highlight certain things. Here it is trying to sort of see whether you can do a vulnerability assessment, a risk assessment based on the vulnerabilities present. Can I continuously monitor the devices which are taking place into this space of cyber layer, which is as applicable for the smart grid sort of scenario. So the key components are the vulnerability management, risk assessment, preventive measures, early detection and continuous monitoring. So what are the basic components for this continuous monitoring is very important. The rest of the thing is mostly offline it is done. So if you want to do online, basically you might not be able to visualize the device at the leaf node which is there in the complete graph or the tree. So I just thought it is better to address at the higher level, which is the SOC, Security Operation Control Center. The basic component or the data source becomes an IDS. So it's an intrusion detection system becomes an important thing. It's a basic component for the proactive security. So that's how the whole thing is being looked at. So what is required is vulnerabilities to identify and fix, continuous monitoring and risk assessment, and you have to have try to see that how the matrices are built based on what is like assurance, cyber assurance metrics to bring out those things and how we can sort of be within the bandwidth. So this is what is as applied to the critical infrastructure is what we are trying to sort of look at. So this is the basic flow of whatever the infrastructure vulnerabilities which are there. Application impact analysis you have to do based on what is the application you are going to run. And what will be the physical impact is very important in this particular thing. If I am able to throw off some load, say very minimal load based on an attack, I would not mind anything for that particular thing, right? Rather than investing a lot of money on the cyber security. So it's the economics, basically you have to see what is the impact it's going to make. And not only that, this is not an individual attack which is possible. An individual will not try to attack. So it's a state or a nation sponsored attack on the critical infrastructure becomes a reality. And that is what has to be addressed. So if you see that when you do on the right side, there are the cybersecurity indicators. Normally pen test is done on the existing system and a lot of systems are given by the vendors. What are the advisories present and given by the vendor? Again, in India, the CERT gives the advisories. So those things has to be sort of monitored and taken care by the vendors. And intrusion detection and monitoring becomes important. So that is why that particular space becomes important. When the application side, you are trying to see the compute and communication parameter. So the compute, you have to do some computation, and communication to send a command. So command control and command communication and control becomes an important. C3I is what normally, now it has become C5I sort of scenario. But we are still at C3I sort of thing. And if the risk is high, then you might have to sort of look at the application security or try to do something on the infrastructure security. That's how the mitigation is sort of looked at. Now the vulnerability is at a different level. So there might be vulnerability at the device level or the access point level or the end device level. There are many devices connected to each other, and there is a system vulnerability which has to also be looked at, and there can be a scenario vulnerability also. So these are three types of vulnerabilities where you have to do a hierarchical modeling, and then based on the formula whatever has been already mentioned, threat, vulnerability and impact. So you are going to sort of follow this particular flow. Based on the risk, you are going to decide whether you will have a defense measures or you will live with the system as is, right? Because defense costs. So at what cost is what you have to calculate and get into this particular piece. So the thing is, what next for the basic intrusion detection system, right? So, and how the privacy and security protection models can be sort of looked at. I think already PETs is what you are trying to mention, but these are two things which are already explored, and there is some things which are happening. I think the techniques to be explored is getting explored also, but getting into the reality is still little far from whatever the things are happening. So homomorphic encryption, I think this is from 2010 people have been talking of, but the actual reality and the implementation has to be looked at because of the uh, performance, basically the time and space performance issues. We might have to look into that particular thing. It is a very good thing to look at, but as getting implemented, we might have to sort of look how these things can be lightweight things can be available, because you need a response time here. Availability is the major component. So we are not having that luxury of the time here to sort of do a large computing. So what are the federated learning is almost everybody has been started talking in the power sector in India also. People are talking about federated SOCs, which will become a reality shortly. So what are the things possible, but what are the things limitations which are existing? So these are two things are existing still, even though there is a lot of things happening, but still they are existing. I think these four things have been three things already in the introduction he introduced: differential privacy, secure multi-party computation, and trusted execution environment. Blockchain is a very fancy stuff, and everybody is trying to sort of get into that particular space. We might have to see again how this particular technology becomes a reality on implementation on a real life or a real system which are possible with a response time limitation. Okay, so these were some of the things which I thought I wanted to tell. Next two slides. Okay, these are all the things which are happening. What is happening in PGCoE is the question which normally people ask. So these are all the things we know, or we can Google and get, right? But what is that? Of course, there is some content which I have put on of my own also, without for the general thing. At PGCoE, this is our main forte. So we enable the research and we collaborate, we engage. Okay, so we don't do everything by ourselves. That is one thing. So we collaborate. So like that, we have got collaborations from IISc, collaborations from IITs, NITs, and national labs. So these are all the collaborations what is happening. So having said that, in the center also we build expertise in this particular area and try to come out with certain things. And we operate on the fundamental research and applied research. Fundamental research, why I say is, this quantum buzzword is a very scary thing which is people have been talking about. And it is most of the time loosely spoken about rather than actual thing becoming a reality. So there are some basic things, fundamental research in the quantum space we are doing in collaboration with IISc. So that's what we are doing. And secure everywhere, secure communication, secure storage, and secure computing. So all these things are being applied. And our forte is power transmission and grid operation. We don't move away from that. What I have showed is from generation to distribution to consumers. So we are not looking at the complete gamut. Our focus is only on the power transmission which is there in India and the grid operations of that particular thing. So this is the only forte what we are looking for. The rest we don't look. Why we don't look? Because this is lifeline of the complete utility and the critical infrastructure. So nothing else. If generator goes bad, I'll throw it out. If load, it is not withstanding, I'll throw the load, but I can't throw the transmission. So it will go to a gray out or a blackout scenario. And the operations of that particular grid has to be pakka. So that's how we are trying to sort of address that particular space. And how are we trying to do? We are trying to sort of enable with the tools and proof of concepts and development of libraries. Research by standard compliance, trying to sort of participate in the standard setting in this particular area through R&D. So that's how the whole thing is. and trying to develop a reference architecture, because this becomes a very important thing, because if you see in India especially, it is all driven by OEMs. So the OEM will come and tell what is required for the end user. So it's not the user telling the OEM. So we are trying to sort of come out with a reference architecture so that the user will be able to tell the OEM, saying that this is what I require. Okay. And of course, capacity building is one thing which is always a gap which is there. So we are trying to sort of do at a higher level, not basic training in this particular space, but it is more of a upskilling and this one, right? So these are all the areas where we have got problem statements, and the research going on, starting from the device level security and the compliance for the supply chain security. And when the sort of system is compromised, we do some sort of a forensics. The whole thing is looked at, including the proactive security in place. So capacity building, these are all the things what we are going to address, again with academia and industry. So this is the conclusion, which this is only to do with the power sector and only to do with the transmission side. Okay, so security is always a three-pillared or a foundation thing. One is the information security, where you get an access to any of the systems. Infrastructure security, there should be an infrastructure which supports certain things. So these are all the things. And application security. Most of the time in this particular area, there is no control over the application security, because generally the application security is some OEM's thing, and the user uses it. That's it. He doesn't know what is the thing happening underneath. He has to configure and use it. So how are we sort of, these are all the needs which are there. So like I told, you should have, for a cyber resilient thing, you should move into a resilient algorithms, right, and control apps. So that's out in generation, transmission, distribution, and real-time markets. That is for the trading purpose, energy trading. So how that particular thing can be achieved is, I think these are all the things which are well understood: encryption, decryption, then a PKI or a digital signature based transaction thing, a MAC and a public key infrastructure thing. When it comes to infrastructure, firewalls are very well sort of looked at: intrusion detection, secure protocol, authentication protocol, attack attribution, secure communication. Because these are all the components which take place in this. At the application level, you have to have attack resilient control algorithms, model based algorithms, which is anomaly detection, intrusion tolerance, bad data elimination. So these are all some basic things which are there in everything, but we don't have a control on the application side which is available, how to handle that particular thing. And risk modeling and mitigation. So these are some of the things which are required in this particular space. And I think we are also generating data sets using our test bed, which is a live virtual and construct model which is there. So we are having some percentage of the whole system of the, I should say, the power grid in India. Some percentage actual physical system we are having, we are emulating and simulating. So we are having a scale up of the complete thing, and we are generating the data sets, and which we will be making it available for researchers for research. So this is what I have to sort of say. So if you're if there is,
Yeah, we'll take one question.
oh, I overdid.
It's okay.
So thanks for the informative talk, sir. So you were saying about that you don't have control over the application security, but that is like kind of the entry point to access these infrastructures and so on, right? So how important is it to build those mechanisms and monitor those mechanisms?
Yeah, if you see in the overall critical information security, that is the thing which is the, like you told, very important thing to be addressed. Having said that, that might not be the major thing to drive a command. There are so many other factors which will be there. It will be validated because the application output is validated and pushed as a command. We are interested in what command goes out, right? A wrong command goes out, the system will go for a toss. Of course, that is very much important because a lot of things are happening on information and infrastructure security, because people always ask, what is the difference between IT security and OT security, operational technology security? So the explanation is that is a major component in the system.
So if
Very
there is a
critical.
breach from the application end, so you're saying that that can be
That can be
detected.
mitigated. Of course, it is critical, but it can be mitigated.
I think in the interest of time, we may have to cut
I'll
the
be
question
here for
short.
some time.
But we can come back to another round of questions at the end once all the speakers are done.